So welcome. I want to introduce our speaker today is Dr. Nestor Perez Mallada. He's a physical therapist, a master in health law, and a doctor in biomedicine and health sciences. During the past 12 years, Nestor has combined teaching at the university with clinical practice and research. And in 2009, he joined the San Juan de Dios University School of Nursing and Physical Therapy of the Pontifical University Comillas as head of physiotherapy studies. At this university, he taught different subjects, and he was the director of the Master of Biomechanics and Injuries Assessment and the Master in Biomechanics and Sports Physiotherapy. In 2007, he left this position to focus his professional development on research through biomechanical tools and specialized teaching activities. He is the technical director of the Clinical Biomechanics and Physiotherapy Research Unit, and his main areas of research are clinical biomechanics and physiotherapy, instrumental biomechanics, and sports physiotherapy and functional evaluation. So I'm going to turn the presentation over to Dr. Néstor, as he likes to be referred to, and we'll let him do his presentation, and then we'll have some time for question and answers afterwards, at which point I'll get you all to line up at the microphone in the back, because this is being taped. So thank you very much, and Néstor, it's all yours.
Okay. Thank you, Dr. Barbara and Dr. Rec, and thank you to the university for inviting me to Illuminate conference. I am very grateful to be in Manitoba University. It's an honor to contribute with this presentation. I'm going to speak about the physical therapy diagnosis with new equipment, and we are going to answer the next questions. What were we using a few years ago? What are we using nowadays? And what could we use in coming years? We are going to divide the presentation in three focus areas: the past of biomechanics, the present, where we will see three parts. One, new equipment without external hardware. We are going to introduce you 2 or 3 apps, and we will be able to download and use them in this presentation. 2, equipment with external hardware. We are going to introduce one research project and one real case, where we will be able to see how to use these tools to do a plant training. And the third, the gold standard, where we will only talk about the difference with the previous equipment. The future, or is the future already here? Before to begin with the biomechanical questions, I would like to comment some issues to reflect on how the technology has changed in recent years. In few years, the changes has been amazing. I don't know could have we live without this system that now are essential and necessary in our life. Only 3-4 examples. 10 years ago, we didn't have Google Maps. I asked myself, how could we arrive to new streets or restaurants only with a paper map? What can I say about the smartphone? Everybody go back home if they forget the cellular on the home table. Do you remember the middle-aged people? When we went on holidays with analogic camera, we never knew if the picture was taken blurred or without light. Well, and now? What do you think when you see cars or buses which are driven by themselves? The changes in the last year have been amazing, but the next changes to come could be out of our imagination. What has all of this happened? Now we have an excellent Wi-Fi or Bluetooth connections. The device uses a better system than 5 years ago at gyroscopes and magnetometers. For example, now you can buy cheaper drones for children that use these technologies. And there is a new software, hardware in constant evolutions. Business companies fight to be the first. And during recent years, what has happened in physiotherapy? How were we evaluating our patient? And how were we teaching and learning in physiotherapy? Easy. We use our hands and easy qualitative tests. we use Enfield, muscle test, round balance, or if we had worked in a high-level center, then and only then we could have evaluate our patient with expensive and complicated biomechanics equipment. And now, in physiotherapy, how are we evaluating our patient? We can continue using our hands, but if we keep doing it, the data will be general and less precise, not accurate, height variabilities, subjectives. However, it's very important to continue using because these tests, they give us a very important feeling to know the evaluation and orientation of our patient. But we have to complete a correct evaluation with a biomechanics tools. Why? Because there are many answers, but I am only going to summarize in 5 points. 1. Sport training and gyms use biomechanics to improve training planning. They use power, they use force, they use weight. We have to communicate to other health science the excellence treatment with objective data. We need to take accurate measurements to improve patients' treatments. Our patients have smartwatch and mobile apps which give them information, heart rate, number of steps, floors up, distance traveled, and there are other science which have improved technology in the clinical treatment and they have changed the organizations and developed in their areas. For this reason, we must to use the biomechanics evaluation with our patients in order to plan objectives and quantitative data. But before to continue, we are going to remind a few issues. Biomechanics is defined as traditionally as mechanics applied to biology through the laboratory measurement system, which are the instruments that are used in order to measure the injuries or disease that the patient suffers. Biomechanics classification has been delimited to 3 or 4 well-defined areas. Medical biomechanics, analyzing disease affecting the human body to general solution able to evaluate, retrieve, or mitigate them. Sport biomechanics, studying the practice of sport to improve its performance, techniques, and training. Occupational biomechanics is the field where the relationship between the human beings and the environment elements, labor, teaching, research, and leisure items are studied to be here adapt them. Legal and forensic biomechanics, analyzing functional modification with medical legal implication. And as a summary, biomechanics is the use of technologies to evaluate different structures of parts of body. And what have been the most important biomechanics change in the last years? It was very expensive, and now we can buy equipment for less than $1,000. It was very difficult to use, and now in 1 hour you can use easily. It was very difficult to understand data, and now there are many easy interfaces. There were few equipments, and now we can find many companies which develop new systems. With this background, we can classify in the present the system of biomechanics in 3 big groups: equipment without specific hardware, equipment with specific hardware, equipment called gold standard, which could be called the classics system. In the present, equipment without specific hardware tools are cheaper and easier to use. We can use our mobiles, which have cameras, sensors, and other internal hardware to take data. We have a very important issues to know when we use these tools. We can use this tool with a patient, but we can't use this system to make report or data comparison. We can't do this because its mobile brand have different technologies, so the result couldn't be compared. But I think it's an excellent opportunity to introduce you 3 apps examples. that are very easy to use and provide interesting data of our patient. The first that we are going to talk about is Goniometro Hawk. We can download it in the Play Store for free or App Store by iPhone for €14. Download is very easy. The first to do is download. Open App Store. The second, type Goniometro Advanced. Be careful. If you find other apps, don't download. Probably you may pay money or you will need to use external hardware. The first that we have to do is download the app. When you have the app open, you can see three different parts. The first part, called Basic, you can see in this area, permit get ROM data in 3 planes, but only can see the maximal room in the planes. You can find the maximal room in this plane. The second, Advanced, permit get room 2, but the big difference is that you can see the graphic line where you find the relationship between room and time. You find this graphic. The other important difference is that you can get the speed and the acceleration from movement and their relationship with the time. The use is very easy because you only have to place the mobile in the part of body you want to measure and select Inicio. That means begin. And whenever you want to stop, you push again in fin. That means end. At this moment, you will be able to see three graphic options. You can see the 3 graphic options: ROM, speed, and acceleration. The 3-part premium, you have to pay it to administer patient. It doesn't have application in biomechanics. Another good app, also free for Android, is iPhone, is Kinematic Jump. In this case, we are going to use the mobile cameras to get data about the time that the patient can be suspended on the air in a jump. With this easy movement, we can know the jump power that the patient makes with his/her lower members. In the example, we can see a jump with 2 legs, but we could make the same jump with only 1 leg, and after compare both. Muscle injuries or scars, low balance, we can measure easily, free, and very accurate with this app. If you don't like the previous app, you can use this app too. It's the same, but in this case, it's costs money. I want to present this app because in Spain it's very popular in some researches and university. However, if we compare My Jump 2 with an Kinematic Jump, the data obtained is very similar. If we don't want to use the mobile to analyze the data, no problem. We can film a video and download it to PC. Then we can use Kinovea for free to get different data about the movement, which could be easy, as a flexion in pitcher, or very complicated, bicycle or soccer kick. I think that all these applications are an excellent opportunity to improve the biomechanics tools in our clinic and begin to take objective data. However, what is the next step? They use equipment which have a specific hardware. This hardware I make it specifically to take measurements of the body. These tools use components and sensors which have been made for other purposes, but we can find an excellent use in physical therapy. They are very accurate and easy to use and need a specific software to take note. If we compare these types of equipment with gold standard, both are accurate, but usually cheaper tools offer less data. we are going to explain an example with a goniometer hog in a possible research in one real case. About the actual research, we are preparing a research where we will work with Paris, USA and Mexico, and hope to be able to offer to Manitoba University to enjoy us in the project. The research has a general objective, which is to identify the parameters of normality in cervical movement in healthy individuals, and has different specific objectives, where we think that the most social relevance could be to compare the variation of ROM, curve, and speed among individual time over the smartphone, laptop, and PC. To take data, we are going to use external tools which sends the data to mobile and use the same interface that we have seen before in the goniometer advance. We will put the hardware in the head and fast and easy take different variables. This system is now called goniometer hog, and you can find it easy in Google. Remember that now we can compare different data from different places because the systems are the same. Preliminary data provides interesting conclusions. We don't have a cervical room as we can find in the bibliography, especially in the rotation movement, where we find a loss of room of around 20 degrees. The second preliminary conclusion could be that the cervical normal speed is a comfortable one easy movement, are the same in all the patients. This aspect could explain the normal cervical movement, and then we will be able to compare it with cervical injury, similar approximation evaluation. We will continue with the research, and I hope Manitoba University will join us. I would like to present a biomechanics tool with a real case, and we want to use the same equipment that we have seen in the international research mentioned. I'm going to introduce the clinical case. Patient is 40 years old. He has a shoulder dislocation because he fell when he was skiing. He has been immobilized during 3 weeks, and afterward he was doing isometric shoulder movement. Now he has to begin to move the shoulder and improve the strength. We have to prepare a training plan. What is the target after anamnesis? The most important for a training plan is to know how much weight do you use, how many repetitions do you make, do we have changed the weight or number of repetitions, are you sure that your training is effective, when do you have to change the weight? Before to know the weight to use in training and number of repetitions, we are going to remind 2 easy questions. The relationship between torque and speed is a lower line where high force has lower speed and vice versa. When we make a multiplication torque per speed, we get the power. The power is very important because it gives us an excellent data to know which weight is the best to make an exercise. If we use more weight to train, we will have more risk to injury, and if we use less weight, we won't improve the patient's strength. Hence, if we use our treatment the correct relationship between weight and speed, we will be able to train correctly in less time. This is the most important change in the classic training. We are going to focus in maximum speed and maximum power with the weight adapted to these variables. To do this, we are going to use the hog system. It's an external hardware that collects speed variables. We will do a fast and easy test which use increased weight. This test is very easy to be performed. If we remember, the problem in this case was in the shoulder. So we need to do a shoulder movement. Abduction, adduction, rotation, flexion, extension. We will select, in this case, abduction and adduction. As you can see, we are going to ask to the patient to do 3 movements at maximum speed without weight. After taking the 3 data, we will calculate the average. And with the multiplication speed per weight, we can find the power. Once the patient has made the movement without weight, we are going to repeat the same movement but with 1 kilo. And we take note. When we finish with 1 kilo, we will repeat it with 2, after with 3, 4, 5, until the patient will not be able to do 3 consecutive movements, or the speed gets very slow, or the patient has pain. When we have finished the test, we will find one graphic line and one graphic band or graphic curve. The line will give us the lower relationship between speed and torque. The curve will give the power, and we will have to focus in 2 changes. The first that we can observe is the change in the power line in 3 kilos, where the patient has to make the first adaptive muscle to continue with the faster movement. We could say that this first change weight will be the resistance data. If we use this data, we will work endurance training. But we see the second change in the power curve in A line, kilos, where the power starts to go down. We can say that this data is the maximum strength. If we use this data, we will work maximum strength. According to our objectives, we could use one or another weight. The next step to training plan will be to know how many repetitions the patient has to do with the weight selected. It's easy and fast too. We select the weight to work endurance or maximum strength. 3 kilos to endurance, remember, or 8 kilos to strength. And we will do another AC test. We have to select the optimal speed movement. We will consider the first speed data as the optimal movement and 100%. The patient has to do the movement until the patient loses the 75 and 80% speed. Then we can consider that the muscle is tired, or we can consider that it's exhausted. How many repetitions can the patient do? 7 in the first set, because at the next movement the speed will be below 80%. Then we have the first set with 7 repetitions. How much time do we have to rest? How much time has the patient used to do 7 repetitions? The rest time will be the double time taken on the 7 repetition, in this case 60 seconds. And then we have to look for the next repetition set number. Repeat the same test and find the number of repetitions from the second set. When will we have to finish the set? When the repetition number gets lower than 80% compared to the first number of repetition set. In this patient, we have found the perfect training plan by abduction and adduction. We have to do the same process to other movements that we have to train: rotation and flexion and extension. In this case, we have make a planning with abduction and adduction, and we can find one set with 6 repetitions, time 80 seconds, minimal rest 16 seconds, and second set with 4 repetition, time to make 5 seconds, minimal rest 10 seconds, and nothing else. When do we have to make new tests or to get new measurements? 7 and 8 days could be fine. If we obtain more power, it's great. The brain training is great. If we have the same power, it's possible that the training plan was very hard and we have to continue training. If we have less power, we have a problem. It's possible the resting time was too short or the patient was doing other activity that fatigue the muscle. What is the future in speed training in physical therapy? We have to do more research to know the different focus areas that enable us to identify the best treatment, the best resting time, the best sequence. We have to propose different research with multiple hypotheses. How many days per week do we have to improve the training? How many repetitions per day do we have to improve the training? How many days do we have to improve the training? Should we train the same for a muscle or tendon or sinew problem? The gold standard equipments are the best. We can obtain many variables with much data to know the patient's situation. The most important problem will be the cost and the knowledge that the therapist needs to use these tools. You can see in the slide 2 excellent equipment, but there are a lot of similar systems. The first is an electromagnetic equipment with a motor similar to electric car. The second uses an electromagnetic engine too, but is complemented with a mechanics disc brake. Both are excellent equipment, a little expensive. Another excellent equipment is the 3D analysis system. We can evaluate the movement with high accuracy, but we will need a previous knowledge and much time to do the evaluation. Other common issue will be the high cost and the big area needed to set up the cameras and platforms. The biomechanics future is amazing because the technology is developing very fast. For example, in few months the PC power of the pixel or the hardware software have improved. We can find new components and systems in internet. There are more companies which work in new projects to find different use or answer to social problems. The big data, the new companies, the engineer degree, many changes in a short time. So it's important to be clear. If we don't change with society and technology, we will stay behind or die out. Only 3 examples for the future equipment. Smart glasses has an amazing development. Now, in this moment, there are software which we can use to study anatomy, to set up components, design or balance training. But there are companies which are working to improve other uses, as sport training in real simulated environments or real situation learning with injury patients. It's possible that the glasses will change a little, or that we will do the same but without glasses. Do you think it will be possible? There are already environments to work without glasses. However, they are too primitive. We can find to work coordination, AC balance, or repetitive movement. But I am sure that in the near future, we will be able to enter in a room which will offer the same possibilities that we have to now with smart glasses. And the last system that I think we'll have to more develop is electric status on the skin. It's amazing the possibilities and healthy control that we will be able to get with this status. As conclusion, now we can't keep using all possible and evaluate our patients in 21st century. In the present, without specific hardware, remember apps, mobiles. If we don't have the biomechanics tool, then we have to use the ones available in the mobile. They are also excellent system to teach and learn biomechanics. With a specific hardware made to evaluate the body, there is an excellent research opportunity, and we have to use with our patient and future research because these are excellent, accurate, and easy equipments. Gold standard hardware and software. We can continue use tools just for a specific patient and special evaluation. The future? Are we in the future already? We need to have an open mind to find a new use and new application in physical therapy. Thank you for your attention.
Well, thank you very much, Dr. Nestor. I'll allow people just to digest a little bit of that and come up with some questions if you have them. I just wanted to start off. Thank you for your presentation. That was very illuminating. Just kidding. Anyway, I have some interest in the smart tattoos that you were talking about. I wonder, have you actually had some experience with those tattoos, and how does that work?
Now, the tattoo is a very new component because they have made in MAD of Boston and in the University of Japan, and they are make the first proof with the patient because it's very important that the data is very accurate because if you put in an pregnant woman, it's very important that the data is accurate and don't fall because the consequence could be very, very high. And I think that is excellent possible in the short future because in 2-3 weeks, in 2-3 months, I have seen different applications from tattoos. I think in 2-3-6 months, we will see the first use in healthy treatment.
So the mechanism by which the data is collected through the tattoo, did you say that was electromagnetic?
They use electromagnetic sensors and they use different systems to take the measurement from the patient. Temperature, pressure, blood, or infrared light. Is similar to the smartwatch that take data about the running, but the sensor is making in a tattoo because the software is very easy to make with an electromagnetic system and it's very flexible.
Very good. Okay. So do you see that these kinds of devices will replace things like accelerometers and actographs and those kinds of things? Is that what you're thinking?
Yeah. Now, if you see in my hands, it's very small equipment. There are 4 electromagnetic accelerometer system, 1 gyroscope and 1 magnetometer, and it's very small. I'm sure that the engineering is working to make this more small and more small. I'm sure that they can find very fast this application. The technology we have very lucky because in the engineer company from Ireland they are making use this technology and they need that the technology are very small. And I'm sure that in the short time we can find this equipment very, very small. And we can put our patients different accelerometers or system to know the body movement during all the day in different parts of the day, similar to the equipment that I use now from the health muscle.
Right. Does anyone have any other questions? I wonder, okay, so one of the main sort of research projects that you're working on now, the multi-site project with Spain, USA, and the other place that you're basically looking at quantifying normal people's neck movement. Is that what you're doing? So you're developing norms with the device that you have, and then the idea would be is that we can then use it for patients who have restricted range of motion and be able to compare that to the norms and see where it is that we need to deliver our treatment. Is that summarizing what your project is about?
Yeah. We want to know the movement from the neck from the patient that don't have problem, because the most important question is to know the range of movement. That there are many bibliography that say what is the correct range of movement, but you can not find speed from this movement. If you take the data about walking speed, we know the average in all patients. But if we know the movement speed in the thermical room, we can compare this correct movement with patients that have injury. This is the reason to take the normal average in rotation, flexion and extension, and lateral band. We want to know this data with women, men's, and different different structure body, to know if there are difference with people that have a very high, very tall, or very short, or very thin, or very big. Because the important is to know the average normal speed. This is the most important objective. The other is relationship with this data with the laptop and time that we are from this equipment, because now we pass a lot of time in front from this equipment, and we think that, and we find bibliography with this data that can make injuries in our neck.
Okay, thank you very much, Nestor. Does anyone else have any other comments or questions? So I think that we're going to be taking some of your information or what you've presented, and people who are doing sort of related research projects, the idea would be is that they would sort of be able to see themselves in a collaboration or, with something that would be somewhat related to what you're doing, and then we would be able to flesh that out even further. So, sort of just to sort of find out our mutual interests and where we could work together. So that would be probably our next step from here.
Oh, okay, perfect. I would like to make the collaboration in this research. I think it's very important to know the difference between the different countries, if the normal movement neck is similar or we have any difference.
I'm just going to ask one last question from my perspective, and that is, how did you come about to think of University of Manitoba in terms of collaborating with Canada as a country? What led you to U of M?
Because I think that the university have a lot of projects in the research, and I think that is one of the most important university. For me, it's an honor to make this conference or these presentations, or to collaborate with you, because I think this is a very important university, and I think that is good for us. And in this case, if you find anything good for you, both could be improved.
Buenas tardes, doctor Néstor. Muchas gracias por su presentación. Mi nombre es Diana Sánchez, soy la directora de Continuing Medical Education y también soy profesora asociada en la facultad. Gracias por su presentación. Quisiera saber un poco más respecto a esa investigación multicenter de la cual usted está mencionando, en relación a qué tipo de muestra pretende alcanzar y con qué fondos cuenta para ejecutar este proyecto.
Do you want that I answer in Spanish?
No, sorry, everyone. I just greet Dr. Néstor and thank him for the very interesting presentation. And I asking him a little bit more information about the current project that he is taking place and the multi-center research. I inquired a little bit more about what's the sample size that they are aiming for and also the sorts of funding they're using at the moment.
Yeah, we are in the first part from the research. We are making the preliminary data to take more or less 30 people from different countries to make the ¿cómo se dice? Yes, a piloted study to make the calculate la muestra, the sample size. Okay, we would like to finish this part in this summer to begin to make the next year to take the data with all the samples that we need in the different places. Unfortunately, we don't have money to make this activity now. We make the project with the collaboration from the different teachers and students for free. We want to make solicitude to the government from Spain to make this research, but now we don't have answer about the possibility to give money.
Thank you.
Sorry, I'm just going to be back to on your camera, and I just wanted to again thank you very much for presenting with us today and staying well past your working time. I hope, as I mentioned to you before, that we continue to dialogue about some collaborations. And thanks once again for presenting to us today.
Thank you for this possibility. It's very nice for me. Thank you very much.
All right. Bye-bye.
Bye-bye.